Hello everyone and welcome back to our video. In this video we are going to talk about the planetary motion, the theories of planetary motion and the most important theory or the most important three laws given by Johannes Kepler regarding planetary motion. So let us begin. So before beginning, I would like to state the name of all those scientists who have given the different theories. Although they were correct or not, that is not the matter. The matter is at that time they dared to give such bold theories. So those scientists include, the first notable scientist was Claudius Ptolemy, then Nicholas Copernicus came, then Tycho Brahe, then Johannes Kepler, then Sir Isaac Newton, and then Albert Einstein. So there is a fact which you need to remember, that Plato was the name of a Greek scientist, Greek philosopher, who said that he was the first person to state that Earth wasn't flat. Yeah, really. Earth wasn't flat. Instead, Earth was round. This statement was said by Plato, and today we know this is absolutely true, that Earth isn't flat; it is round. So let us begin with the theory of planetary motion that was proposed by Ptolemy. So Claudius Ptolemy in 2nd century AD he proposed his geocentric or Ptolemaic theory. In the theory, he stated that Earth is the center of the solar system. All the other planets, sun, moon, all the other celestial bodies of the solar system revolve around Earth. And this theory came to be known as geocentric theory. Why geocentric theory? We know that geo means earth, centric means center. So the theory states that earth is the center of earth. That is why it is known as geocentric theory. And since it was given by Ptolemy, it also came to be known as the Ptolemaic theory. This was the scientist in the picture, as you can see. Moving ahead. So next scientist was Nicholas Copernicus, a very well-known person in the field of geography. In He also contributed a lot in map making. So in the beginning of 16th century, he proposed that the sun is the center of the solar system. Yes, he proved the previous scientist Ptolemy wrong by giving his heliocentric theory. In his theory, he stated that Earth isn't the center. Instead, Sun is the center of the solar system, and all the celestial bodies, all the planets, including Earth, revolve around Sun. So this theory came to be known as heliocentric theory, since helio means sun. And since it was given by Copernicus, it also came to be known as Copernican theory. Moving ahead, we have Tycho Brahe. So Tycho Brahe is also a well-known name because he made several astronomical calculation measurements which formed the base of Kepler's law. So his astronomical measurements over a period of 20 years by observing the motion of planet was very much useful for the upcoming scientists. So he was also a notable very good scientist. Moving ahead to Johannes Kepler. So this is the scientist who gave the three most famous laws of planetary motion. So he summarized the planetary motion, the concept of planetary motion, by giving his three laws. And his laws are widely accepted even today. In most of the books, whenever you study gravitation in 9th or 11th, you came to this Johannes Kepler's three laws regarding planetary motion. Yeah, so moving ahead, after Johannes Kepler, Sir Isaac Newton gave his universal law of gravitation. For his universal law of gravitation, he needed this law, that was the inverse square law. So this inverse square law was deducted from the Kepler's third law, that was the law of periods. So it was deducted from Kepler's third law. Which rule? The inverse square rule was deducted from Kepler's third law. Moving ahead to Albert Einstein, we know that he stated that the space The universe is a space-time fabric. That means the body having heavier mass makes quite large bend in the space-time fabric as compared to a body of lower mass. As in the picture you can see, the sun has made a quite a large bend in the space-time fabric as compared to the earth. So his concept was completely different from other scientists. So moving ahead to discuss the Kepler's three laws in detail. So in the year 1618, Kepler came up with his three most famous laws of planetary motion. So Johannes Kepler, very famous scientist. So his first law was the law of orbits, since this law describe the orbit of the planets around the sun. So the first law states that all the planets revolve around the sun. All the planets revolve around the sun with the sun situated at in an elliptical orbit with the sun situated at one of the foci. That means what? Any any planet do not revolve around the sun in circular orbit, but instead the planets revolve around the sun in elliptical orbits. Ellipse is a shape that is quite similar to oval shape, oval or parabola. It is quite similar to that. So ellipse has two foci, just like a circle has one center. An ellipse has two foci. On one focus, on either of the two foci, the sun is located. So the planets move around the sun in an elliptical orbit, and the sun is situated at one of the foci of that ellipse shape. Now, talking about some more terms regarding planetary motion, we came across perihelion and aphelion. So, perihelion, that is denoted by the point P, is the point which is closest to sun. The point where the planet is closest to sun is known as perihelion, and the point where the planet is at the longest distance from the sun is known as aphelion. So perihelion and aphelion are the closest and the longest points respectively. Now, talking about two more terms, that is perigee and apogee. So, perigee is the shortest distance of the planet from the sun, and apogee is the longest distance from the planet from the sun. R1 is the perigee and R2 is the apogee. Moving ahead to knowing more about an ellipse. So, as you can see, this ellipse is an oval similar to an oval shape. So it has two axes, major axis and minor axis. This AB is the major axis and this CD is the minor axis. And the half of the major axis is the semi-major axis, that is this AO or OB, and it is denoted by A. And the half of minor axis is the semi-minor axis, that is denoted by B. And this R1, R2, R1 is the perigee, R2 is the apogee, and perigee plus apogee is equal to major axis. And what is major axis? 2 times of semi-major axis. So R1 plus R2 is equal to 2A. Moving ahead to Kepler's second law, this law is known as the law of areas, since it describes about the area swept by the planet. So this law states that the aerial velocity, what is this aerial velocity? Area swept by the planet per unit time is the aerial velocity. So the aerial velocity of a planet around the sun is constant. That means what? The line which you can see, the line joining Earth and the sun, the line joining Earth and the sun, or the line joining any planet to the sun, sweeps equal areas in equal intervals of time. That means what? The areas A1, that is in blue color, A2 of green color, A3 of orange color. So these three areas will be equal. That is A1 is equal to A2 is equal to A3. And the condition is if these three distances S1, S2 and S3 are swept in equal intervals of time, are swept in same time. So that is the condition for this law. So this was all about the second law. Not very much tough. So moving ahead to Kepler's third law, that is the law of period. So in the law of period, the Kepler described the relationship between the time period of a planet and the mean distance. So what is the time period of a planet? Time period is the time taken by the planet to complete one revolution. The time taken by the planet to complete one revolution is the time period. And according to the Kepler's third law, the square of time period is directly proportional to the cube of mean distance. What is this mean distance? A, also known as semi-major axis. So, square of time period is directly proportional to the cube of semi-major axis. So, t square is directly proportional to a cubed. So as you can see, this R1 plus R2 is the semi-major axis. So R1 plus R2 is equal to 2A. So A, that is semi-major axis, will come as R1 plus R2 by 2. So I can replace this A in the relation above by R1 plus R2 by 2. So T square is directly proportional to R1 plus R2 by 2 whole cubed. So this is the relation we have derived. So this was all about the Kepler's law. In detail, we have described all the three laws, and the theories regarding planetary motion we have described broadly. So that's all about the video. Thank you and have a nice day. Thank you everyone.